In this tutorial, we're going to create this grenade using subdivision modeling and then transfer our high poly details down to a low poly version. This is a common workflow for game development because it allows game engines to render very realistic detail with much less geometry. For example, the high poly for this final grenade ends up being over 100,000 triangles, while the low poly model that we'll export will end up only being 2,400. The key difference between sub-D modeling versus standard modeling is the use of smoothing to achieve the end form. A good example would be creating a skateboard ramp. With standard modeling, you'd actually create the exact geometry that the ramp will need, but with sub-D modeling, you would try and keep your base model as simple as possible and then use a modifier like turbo smooth or NURMS to smooth the model. You can see you get a much smoother curve on this ramp and everything is clean and equidistant. Now, if we try and extrude out the top of the ramp and the backside, we can see that the smoothing averages it all out into one swooping curve. To get the hard edge back, we would need to add supporting edges on each side of the edge that we want to maintain. Swift Loop is a great tool for doing this interactively. This is essentially the sub-D or hard surface workflow. Create simple geometry, toggle on the smoothing to see how it looks, and then add supporting edges around the details that you'd like to maintain. Alright, let's set up some hotkeys so that we can toggle our smoothing and add swift loops quickly. Let's create a simple cube, right-click the mesh and convert it to Edit Poly. Now add a Turbo Smooth modifier on top. Next, to toggle between our low poly object and the smooth version, we need to hotkey this Show End Result button here. To do this, go to your Customize menu and choose Customize User Interface. Next, just start typing Show to filter down the list. Locate Show End Result, and with it selected, you can enter your hotkey in this field and click Assign. Let's also find Swift Loop and assign this as well. Okay, now we can test our new hotkeys. Select Editable Poly in your modifier stack and then press your Show End Result hotkey to toggle the smoothing. Next, let's add a few supporting edges with Swift Loop and toggle the smoothing back on to see the results. Great, now that we have this working, we're ready to start modeling our grenade. I'll start by switching to the top view and pressing T, and I'll create an 8-sided cylinder. When creating any kind of circular detail with sub-D modeling, you want at least an 8-sided circle so that it smooths perfectly. A 4-sided shape with smoothing gets close to a circle, but it's slightly distorted. I'm also going to leave my height segments at the default 5 because the grenade has 5 vertical grip nubs. Next, I'll adjust the proportions using the Scale tool, or R. Right now I intend to use this geometry as the main body and I'll extrude out the neck later. After adjusting the scale, we should jump over to the Utilities tab and hit Reset Xform and then Reset Selected. This resets all the transform information we've just done to the model so that we're now looking at its default state. Before we go further, we should create a simple diffuse material that matches the color and specularity of our reference. This way we can try and match how the lighting diffuses across the surface on our reference image. Just select an empty material ball, drag it onto your object, and then click the color box next to the diffuse. You can actually use the eyedropper to sample directly from your reference. Now I'm going to delete the top and bottom faces of the cylinder since we'll manually extrude those later. Next, let's add a Turbo Smooth with 2 iterations to the modifier stack and choose Isoline Display. This will display our low poly wireframe onto our Turbo Smooth mesh. Now I'm going to adjust the speck and gloss in our material a little bit more so that the highlight is closer to our reference. Alright, that looks pretty close. Let's switch back to Edit Poly and then toggle off our Show End Result so that we're seeing the unsmoothed geometry. Select Polygon Mode and hit Ctrl A to select all. Now we can easily get those grip nubs by going into our bevel options. By default, it will extrude the entire selection as a group, but we can change this to polygon so that each face has its own bevel. For the first bevel, we want the height to be very low so that it's almost just an inset. This basically gives us a nice border edge around our nubs so that it's going to smooth nicely. Now with the same selection, let's do another bevel to add the height. And we can also just hit this Apply and Continue button to add one last bevel on the front of the face. You can right-click any one of the input numbers to zero them out, so do this on the height so that we just get the inset. This also acts as another support edge for the front. Remember, you can use your Show End Result shortcut while beveling if you're curious how it's smoothing. This seems to be smoothing pretty well, but our box shape is getting wiped out. We can remedy this by selecting this top border and then switch over to our edge mode and press Alt-R to ring select all the front vertical edges. Next, go to the connect options and choose 2 segments and increase the pinch so that the segments move outward, creating new supporting edges on all of our nubs at once. It's best if you get this dialed in right now, so just keep adjusting it here until it matches your reference. Okay, remember to use F4 to toggle your wireframe on and off when evaluating your mesh. Now that we have our nubs, I'm going to darken the diffuse some more to match the reference. Okay, now we can add the actual taper to the body using an FFD 3x3x3. Once you add the FFD, just right click and choose control points, which will give you a simplified lattice to make broad changes to your model. I recommend lining up your mesh in front of your reference and select the middle row of FFD points to scale them up, and then I'll scale the bottom row down to better match the taper. Once you're happy with the proportions, you can right click the FFD modifier and choose collapse so that it becomes applied to your edit poly. Technically, you could leave it live, but then when you're working on your edit poly, you wouldn't see the effect of the FFD, making it hard to make informed decisions about the geometry. Now let's select the bottom loop and shift drag it down one segment. Notice that because of the supporting edges, the shape is octagonal. If we want it to transition to a circular base, then we'll need to terminate some of these edge loops first. We can do this quickly by switching to the front view, selecting the bottom row of verts, and then open the weld options so that we can increase the threshold just enough so that the supporting verts collapse and weld with the center vert. Now this is smoothing much better at the base, but the octagonal shape is still coming through the above edge loop. I'll repeat the weld process on this row and then lower and adjust the scale. That's starting to look okay, so let's finish off the bottom by shift dragging the open edges and scaling them down. For the bottom, I'll shift drag once more and collapse it to a single vert. Let's check the smoothing and move the bottom vert until it smooths perfectly. Now we'll do a similar technique for the neck of the grenade. For the first edge loop, I'm not going to go very high because I want the smoothing to retain the little ledge that's present on the top of the grenade body. Now we extrude the next one all the way to the top. Next, we want to flare out these edges so that this shape is closer to the inset groove seen in the reference. We can start by selecting these middle faces all the way around and then converting the selection to vertices. To convert the selection, just hold Ctrl and select the vertex subobject mode. Next, deselect the top row verts by Alt-dragging over them. Now if we constrain our vert selection to edges, we can slide them up along the pre-existing geometry. This way we keep our main form intact. Okay, next we can select all of these inset faces and then add a bevel. Again, I'm checking my smoothing while the bevel is active to make sure I get the depth right. This is looking okay, but I need the base of this bevel to push inward to match the reference closer. I can select the center vertical edge around the model and convert it to vertex selection as well. By converting it to vertex, we can use the scale tool to help shape our selection with more control. Oops, I still have edge constraints on here, so let's uncheck that and then scale this selection inward by only scaling on the X and Y axis. Now I'll use Swift Loop to add a supporting loop directly above so that the edges of the inset shape don't smooth too much. Using the same technique as before, I'll also scale these verts in so that the inset has a smoother transition. Okay, now let's add a Swift Loop at the top and shift drag another edge loop above our new details. You might have noticed that we have the same octagonal problem here that we had on the bottom. Fixing this is a little tricky because any adjustments we do will need to also apply to the other insets around the model. One solution is that we can select one cluster of polys and then detach it as a separate object. Next, delete all the other similar details on that main mesh. Now select our new detail piece and add a single connect down the faces that border our inset. Delete the outside faces and then enable angle snap at 45 degrees. We want it set to 45 because we're going to recreate our 8-sided shape, and 360 degrees divided by 8 is 45. Now we can shift rotate, and when the clone options pop up, choose instance and change your number of copies to 7, which gives us 8 segments altogether. Remember, with instances, we can change any one of these and the others will update in real time. It also rotates around the object's pivot point, and since we detached this piece from our main mesh, it automatically inherited its pivot point, making our rotation snap work perfectly. Technically, we could have also used this technique on the actual grip nubs if we're having trouble getting those shapes dialed in. Now let's add a turbo smooth onto this new piece and fix its smoothing problem. I'm also deliberately working on the piece that faces directly forward so that my axis gizmos are nice and straight. Now we can move these side edges out to manually round out this form. Again, I left constraint to edge on, so make sure that's off. Let's also jump into the top view and slide these edges over to make sure they're close enough for a weld later on. Alright, that should smooth much better, and don't worry about the harsh edges on the outside. They'll average out once we weld it back to our main mesh. So let's cut the turbo smooth from this piece, select one of them, and right click and convert to Edit Poly. This breaks the instance connection from this piece so that we can attach it with the other pieces. Now, before we attach the top to the base, we should add a vertical division in the middle of these nubs so that we can easily weld both pieces together. Let's select the open middle edge of each top nub and then press ring select all the way down. Now use Connect to add an edge loop straight down the center of everything. Remember, Connect remembers the settings from your previous Connect, so in this case we can just use the hotkey Control-Shift-E to cut down the middle. If your last Connect wasn't a single segment middle Connect, then you'd want to go into the settings again and manually adjust it. Now that we have these middle edge loops, we might as well use them to round out the nubs so they're closer to our reference. Again, we can convert this selection to vertices and then scale on the X and Y to push them out. Now that we've rounded out the center, our other supporting edge loops are interfering with the shape. To fix this, we'll do the exact same thing until we get a nice round surface. Oh yeah, those are some nice looking nubbins. Now let's just select the base of our Edit Poly and attach the top piece. The reason we removed the turbo smooth from the top piece is because we already have one applied here and wouldn't want to double up smoothing on top. Once attached, we can select the top piece using element mode, then convert the selection to vertices and use weld threshold again. This also inherits our last weld, so I'll zero it out and then increment it slowly so that we're only welding the open edges. If you go too far, it'll start breaking down important geometry, which we don't want. Remember to pay attention to the before and after vert count to make sure you're actually welding something. Now we also need to weld the shared open edges of the top and bottom piece. This could be done all at once, but sometimes it's safer to weld smaller sections so that you can dial in the threshold for your specific need. Okay, now let's go back to the top, select the open border, and shift drag slightly up and then shift scale inward to get the nice crisp edge on top. We can also just continue this approach for this top red plastic or rubber insert piece. I do apologize to any creepy grenade experts for not knowing its military term. Now I'm noticing this top piece isn't smoothing perfectly round because of the geometry we extruded it from. To fix this easily, I'll select the horizontal edge loop that separates the two halves and then use split to unweld the verts. Now we can remove the unwanted edges from the top piece without disturbing the topology of the body. Alright, now we're finished with the main body, so let's move on to the head of the grenade. For this, I'll start with a simple plane in the front view. Next, I'll convert it to Edit Poly and I'll right-click and enable See-Through so that I can manually adjust the proportions over the reference. Next, I want to set up a symmetry modifier so that we can just focus on modeling one half. Before adding symmetry, let's go over to the Hierarchy tab and press Effect Pivot Only. Now I'm going to move the pivot point back on the Y-axis since the symmetry modifier will mirror around this point. Okay, we're ready to add symmetry now. Next, pick the appropriate mirror axis and add a turbo smooth above the symmetry modifier. This is a great setup for modeling objects that have an even thickness to them. We can turn off the turbo smooth's visibility by clicking this light bulb icon here, so that when we use our Show End Result shortcut, it'll be limited to toggling the symmetry. I'll jump down to the Edit Poly level and then shift drag the edge towards the center to start blocking in the curved front. Now when I turn turbo smooth back on, I can see that just the simple edge extrusion is smoothing out quite nicely. I'll add an additional swift loop to the front so I can control the shape more, and I'll shift drag out the back edges to complete the base form. Now I'm going to spend a few minutes dialing in the base metal material, and I'll also adjust the proportions slightly to better match the reference. Okay, our next order of business is to add a few new swift loops so we can extrude out additional details from this base mesh. Now before extruding out this front lip, I'm going to manually cut a border around so that when we smooth, the supporting edges terminate nicely. Now just select the faces and go into Extrude Options and Extrude by Local Normal. This way it flares out evenly and stays connected at the corner. You might as well toggle on the smoothing before you commit to make sure. Okay, so the midpoint needs to be pushed in a bit so the symmetry can auto weld that. That's better. Now we need to use swift loops to reinforce all these main edges so they don't round off. Now let's pull out this front bubble and add an edge loop towards the bottom so that we get a slightly sharper edge there. Throughout the process, I'm constantly adjusting proportions and making sure I'm still matching the reference. Now I'll take this bottom edge and shift drag it around at even increments to form the round lip of the grenade. Next, I'll manually drag out a border edge from the front view, and I'll add a swift loop below and use target weld to connect the new edge loop to our base. This gives us a nice clean supporting edge that flows in the same direction as our lip piece, which will make for a nicer, non-pinchy subdivision. Next, I'll just shift drag the top edge over to complete the top surface. Now I can select edges on the top and bottom and then use the bridge tool to surface between them. I've also deliberately spaced my verts so that the bridge doesn't have to stretch too far horizontally, which might introduce pinching. Next, I'm going to manually smooth this bottom corner out because some of the new supporting edges are squaring it off. After some unsuccessful tweaking, I realized that this vertical edge is causing the main form to appear harder than in the reference. I can select the bottom half that is causing the issue and hit Control Backspace to remove it. Now we can manually cut from this unresolved vert in a curved downward direction so that its surface smooths more gradually than before. Again, these are the types of issues you'll constantly be fighting with. Something isn't smoothing correctly, so you add a few edge loops to fix it, and then you realize those new edge loops introduce more problems that need their own solutions. More often than not, the solution is to either gradually space them out and manually smooth the curve, or to terminate the edge loops somewhere flat like the middle of a surface. I'll spend a few minutes and finalize this base form before moving on. After looking at a few more shots of this MK2 grenade, I realize that the top lip piece curves inward a bit. Okay, the next challenging detail is adding this vertical box extrusion. I'll start by moving the reference over slightly and then add a few new swift loops so that it lines up with the image. Now let's select these faces, delete them, and straighten out these open edges. I'm going to start this by shift dragging the top out and then down, and add the necessary supporting edges. Next, I'll form the sides by shift dragging inward, and then we'll add some swift loops here as well so that the geo matches the main form underneath. Basically, we need the same amount of verts on all of these open edges. Now we can just use target weld to stitch it back together, and I'll also add more swift loops as I need them. Now the piece is smoothing okay, but these new edge loops are interfering with the main form now. To fix this, we'll select the entire loop, then deselect the portion around our new detail and hit Control Backspace. Next, just use target weld to manually terminate these open verts. This spot took a bit of troubleshooting to get the smoothing nice. The solution was manually curving the verts on the left side so that they smoothed with the front curve more naturally. Okay, now I'm also going to push this back edge in a little bit to match the reference. So another really important skill to get comfortable with is cutting in new shapes so that you can extrude them or push them in. Even though this cylindrical inset is very shallow, we should still model it in there. First, let's go over to the Shapes tab and choose Circle. Drag it over the reference to approximate the radius, and then expand the interpolation drop-down so that you can change the steps to 1. This will give us an 8-sided guide that we can use to cut the shape into our existing geometry. Next, let's position it close to where we want the new detail, and I recommend turning off your turbo smooth so that you can see low poly geometry. I'm going to weld these points so that we can get a nice clean surface to cut into, and it will make things easier if we move some of the surrounding geometry in a bit. I'll also add a new vertical edge loop so that we get more geometry that we can terminate our cut edges to. Next, right-click the snap tool and double check that you only have vertex selected. Then turn on the snap by either pressing the button or the S key. Now enable the cut tool by pressing Alt-C and trace around the cut guide by clicking on each of the 8 points. Don't worry about the auto triangulation. This will continue to update throughout your cut, so just continue around the shape. Notice that the depth of our guide doesn't matter as long as we are in a flat view like front, side, or top. Double right click to end your cut and deactivate the cut tool. Cut can be really frustrating if you haven't used it much, so the double right click is a good trick to remember. Otherwise, you'll just keep cutting up the mesh until you punch your monitor and explode yourself in your room. Okay, now switch to face mode and delete the inside faces. Let's toggle on your turbo smooth and see what's happening. We do have some weird smoothing around the edges, so to fix this we need to do a little cleanup. Let's go back to our low poly and connect these open verts to the verts diagonal to them using the connect tool. You can just select 2 verts and hit Control-Shift-E. Alright, that's much better. Now let's select the open border and shift scale it down slightly to get our initial supporting edge. Then I'll shift drag in a bit and also shift scale inward. Okay, now we have a nice clean circular inset. Next, I'm going to shift drag this geometry over for the additional details. I'll clone to element so that it's still part of my object, and then I'll just float this above the base rather than having to weld into it. This is an example of a floater, and is a common technique used for small technical details that might be annoying to model in. Once we bake this down to a normal map, you won't notice that it's a separate piece, and it just saves a lot of time. Especially if you have hundreds of little punched out machine holes or something like that, you definitely want to use this technique. And things like small rivets, screws, stuff like that. Great examples of floaters. Okay, now we're getting close, but we still need to model the thin cover piece on top. Anytime you start a new detail, you should look for existing geometry that you can copy so that it's already in the correct position, scale, and rotation. Obviously for this, I'll copy a few of these top faces here by shift dragging them. As I copy these, I should have chosen object because I ended up having to detach it right away anyway. Now let's space these edges out a bit and start shift dragging some of the edges down to form this side lip. We should also set up a turbo smooth on this piece so we can evaluate the curve. For this front curved part, I'll shift drag it over and around our existing form, and I'll adjust the verts as I go so that the geometry flows in the correct direction. After you get the side right, switch to the top view and make sure you adjust it here as well. Remember, you should always check something from at least two different views, like the top and side or top and front, to make sure everything's in the right space. Notice we're not worrying about the actual thickness of the geometry yet. We'll get to that once we have the main form nailed down. Alright, so I modeled this back piece out using the same edge modeling technique, so hopefully you realize how versatile this workflow is. I've also set up a symmetry with this piece as well, and now we can start looking at the whole form. After looking at some additional reference, I've decided to add some grooves on this back safety lever. Okay, now to add thickness, let's jump to our edit poly and then add a shell modifier so that it inserts before our symmetry and turbo smooth. I'm going to shell using the inner amount since we've already carefully lined up the model to our reference. I've also temporarily removed the symmetry so that I can select the bottom edge and split it. Now I can easily select the inside geometry, delete it since it's not visible at all. More importantly, these bottom edges will smooth very nicely now since they aren't trying to smooth around to the underside. This saves me the trouble of having to add a bunch of unneeded supporting edges. Next, I'll drag these edges down so we can see more of the edge thickness in our final render. Again, this is the same concept as exaggerating the taper from our box before. Alright, we're almost done here, but let's create the safety pin by going over to the shapes and using a helix. Now click and drag out the initial radius, let go, and then left click twice to complete the creation sequence. Now we can switch back to our perspective view to tweak the height and turns amount so that it matches our reference closer. Change your sides to 6 and expand the rendering tab and check enable and viewport so that we can actually see the thickness of the spline. The reason I dropped it to 6 sides is because this will actually be our low poly mesh. It doesn't really make sense to bake simple cylindrical objects like wires, pipes, or hoses to a low poly cylinder because with a soft smoothing group, the low poly will already shade nice and smooth, so it would be a waste of texture space. Also make sure you have generate mapping coordinates checked since it gives you a free, clean UV map automatically. Now let's convert this to edit poly, switch to face mode, select all, and go all the way down to our smoothing group buttons. Choose an unused group to assign all of these faces to one smoothing group, which creates a nice soft shading. Now this looks pretty good except for the end pieces, so let's select these as well and give them their own group and then deselect the previous group. Okay, now you get a nice hard edge on the end and smooth around the coil. So let's slide it back over and I'll change the pivot point so it rotates around the actual point it'd be connected to the grenade head. We can also select this edge loop here, press create shape from selection, choose linear, and then select our new spline to adjust its thickness. Then just convert it to edit poly and give this its own soft smoothing group as well. Okay, now the last thing to do on the high poly is to surface the backside of this safety lever, so you can just shift drag them inward and then add a new symmetry if needed. Now I'm having some nasty smoothing right at the bottom, so I need to clean up this geo and adjust the mirror axis of my symmetry. I also need to manually cut in some supporting edges from this bottom edge. Okay, awesome. That wraps up the high poly portion of this exercise. In the next chapter, we'll construct a low poly mesh, unwrap the UVs, and then bake out a diffuse, normal, and lighting map. Then we'll take those textures into Dedo to refine our material and export new textures. Last but not least, we'll export it over to CryEngine and evaluate it in Engine. Thanks for watching.